applications involving right triangles. Notice in this right triangle, angle A is capital A. Across from angle A is side A. Angle B is capital B. Across from angle B is, or opposite angle B is side B. That's small letter b. And capital C is letter C, and its hypotenuse is small c. So we're asked to solve this triangle. Well, one thing we know that the interior angles of a triangle have to sum to 180 degrees. So we know that angle B plus 34.2 degrees plus 90 degrees is equal to 180 degrees. So that means angle B is going to be 180 degrees minus 34.2 degrees minus 90 degrees. So this angle B here will be 55.8 degrees. So we can add that in, 55.8 degrees. So when we're asked to solve a triangle, that means find all sides, all three sides, and all three angles. Now that we know that, we certainly could find side A, because we know angle A is opposite. If we take the tangent of angle A, we're going to do opposite over adjacent. So that means tangent of 34.2 degrees is equal to opposite is A over 19.4 is B. So that would imply that A is, if I multiply both sides by the denominator, I get 19.4 times tangent of 34.2 degrees. So A, when I put that in my calculator in mode degrees, I'm going to get A is about 13.18. So A is 13.18. Notice they didn't give us units here. They just gave us a number. So finally, I know that this was given. This might be wrong. I think it's right, but it might be wrong. So if I'm going to calculate C, I want to use as much given information as possible. I know that the cosine of angle A, which is 34.2 degrees, notice that was given, is equal to adjacent B, 19.4 over C. Now, that leaves me working with numbers that were given. I know this is correct, and I know this is correct because it was given. So if I multiply both sides by C, I get C times cosine of 34.2 degrees is equal to 19.4. And if I divide both sides by cosine 34.2 degrees, I get C is equal to 19.4 divided by cosine of 34.2 degrees. So C, this is side C, is going to give us about 23.46. Now, again, I don't know the units of that. So in summary, we solved the triangle. We were given this, and we figured out this and this and this in green by using trigonometry. And that's what solving a triangle means. We have to find all three sides and all three angles. Notice, smallest angle across from smallest side, medium angle across from medium side, and largest angle, 90 degrees, across from largest side. We have a side angle relationship that follows that pattern. A safety regulation states that the maximum angle of elevation for a rescue ladder, remember, an angle of elevation is always going to involve a horizontal, is 72 degrees. A fire department's longest ladder is 110 feet. What's the maximum safe rescue height? This is what we need to know here. How high can someone be and still get rescued? Well, we know, I say draw a picture. Here's our fire truck, and with the horizontal, I make a 72 degree angle. So I know that sine of 72 degrees is opposite, which I'll call A, over hypotenuse, which is 110. So A is equal to, if I multiply both sides by the denominator, 110 sine 72. Got to make sure my calculator is in degrees. So A is equal to about 104.62 feet. Now, that's what this distance is here. So all we can say is the maximum safe distance or safe height of getting someone out of the fire is 104.662 feet above the truck. Now, we could go out to the truck and measure and find this and add that on. We could take a guess that's about 10 feet high. So a person could be as high as maybe 114 feet or so and still get rescued, because we'd have to add the height of the truck onto that as well. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees. So here's the base of the building. I'm 200 feet away. And remember, angle of elevation is always with the horizontal. I'm going to be looking up at an angle of 35 degrees. The angle of elevation to the top of the smokestack is 53 degrees. So this angle here, this big angle, is 53 degrees. I'm not talking about that little wedge of cheese there, but the whole thing is 53 degrees. Find the height S of the smokestack alone. All right. Well, I don't know. I'll call this B for building. I don't know how tall the building is, but I do know that tangent of 35 degrees, which is this small angle here, is equal to B over 200 feet. That means B is equal to, if I multiply both sides by the denominator, 200 tangent of 35 degrees. You know what? I don't even have to find out how tall the building is. I'm not interested in that. The building is not so much my concern. I mean, I need to know what it is, but I don't have to actually come up with a number of that. Because if I do the following, if I say, well, tangent of 53 degrees is equal to, that's B plus S over 200. I'm sorry, B plus S over 200, just here, right? And that means that B plus S is equal to 200 tangent of 53 degrees. So I've got this distance and this distance. So if I do B plus S minus, come on now, minus B, then I'll be left with just the height of the smokestack, S. So B plus S, that's this distance here, is 200 tangent of 53 degrees, and I'm going to subtract from that the height of the building, which was 200 tangent of 35 degrees. Now, make sure your calculator is in degrees. And when you do that, you'll get about 125.37 feet. Notice you could have found out, you could have converted this to a number, and you could have converted this to a number and then done this minus that. But I chose to just use my calculator once. I said this figure, I did this figure minus this figure. Right? I did the blue minus the black. But you could have found the number for this and then the number for this and done this minus that. I chose to just keep it as a trigonometric expression and do one minus the other and let my calculator do the work for me. A swimming pool is 20 meters long and 12 meters wide. The bottom of the pool is slanted such that the water depth is 1.3 meters in the shallow end and 4 meters in the deepest end. Find the angle of depression of the bottom of the pool. So remember, angle of depression is always going to involve the horizontal. So here is our unknown. We want that angle. If this is 1.3, and when I bring this over here, then this is 1.3 here as well, which means that 1.4 minus 1.3, I have 2.7 here. So if this is 2.7 and this here, well, if it's 20 meters at the water surface, it'll be 20 meters underwater as well. That allows us to say